Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 42. Today we will be looking more at circles and the arc length. So we've learned that the measure of the arc is equal to the measure of its central angle. Let's learn more about arc length. First, let's look at the picture of the clock. What is the measure of the arc from 12 to 1? We know the entire circle is 360 degrees, and the clock is divided into 12 segments, those hours from 1 to 12. So 360 divided by 12 would give us the distance between one of these numbers. And the answer to that is that it's 30 degrees. But let's look at the hour hand. If it moves from 12 to 1, it only moves this much. What about the minute hand? It's way out here. If it moves from 12 to 1, it moves this much. So the length of the arc is variable depending on the size of the circle. This hour hand is not as large of a circle as the minute hand is going to make. So even though the arc measure is the same, the arc length is not. Let's look at another example. What fraction of its circle is each arc? So on this first circle, T, we have the arc AB. If the central angle is 90 degrees, that we know the arc is 90 degrees, that means it's a quarter of the circle. It's 1/4 of the circle. Because if we were to keep drawing, we would get 4 90-degree angles within that circle. What about CED? What fraction of the circle is that? Well, it looks like a semicircle. It's half. We also know that this straight line is 180 degrees, and 180 degrees is half of the 360 total. EF. What about the arc EF right here? It's 120 degrees. What fraction of the circle is that? Well, if you don't know off the top of your head, you could say 120 over 360. That's the fraction of the circle that it is. We could reduce that by dividing both by 12. By dividing both by 10 and making this 12 over 36. We can then reduce by 12 and say that it's 1 over 3. It's 1/3 of the circle. So arc measure versus arc length. What do fractions have to do with the arc length? Well, if you traveled 1/4 of the way around the circle, how much of its circumference have you traveled? Again, you've traveled 1/4 of it. The circumference is the distance around the circle. So if you are going 1/4 of the distance around the circle, you're going 1/4 of the circumference. If that circumference around the entire circle was 4 feet, how far did you travel when you only went 1/4 of the way around? Well, you only traveled 1/4 of 4, which is 1 foot. So the arc measure is measured in degrees. In this case, the arc measure would be 90 degrees. It's equal to the central angle, also measured in degrees, but the arc length is the fraction of the circumference the arc is. It's an actual distance. It should have a length unit, like this one being 1 foot, or it could be in inches or meters or centimeters. So let's do an investigation on finding the arcs. Here we have arc AB, CED, and GH. We're going to find the fraction of each circle that the arc is. Then we'll find the circumference of the total circle. Then we'll combine those results to find the arc length. So let's start with the fractions. Right here, AB is 90 degrees. So 90 over 360 is 1/4. Let's do this fraction. CED This is a straight line, so this central angle is 180. The arc is 180 degrees, and 180 degrees over the total 360 degrees is half the circle. GH, it's 140 degrees. 140 degrees over the total 360 degrees. We can reduce that by a factor of 10 and put it as 14 over 36. We can then reduce again by 2 and say that it is 7 over 18. And if we keep it in a fraction, that's the lowest fraction that we can get to. Now let's go back and find circumference. We only have the radius in this case, so the circumference is 2 pi times the radius. So 2 times 12 would be 24 pi. And if we use the pi button on our calculator, we're going to get 75.4 meters. Let's go to this next circle. The radius is 4 inches, or the diameter is 8 inches. So we could use pi d and say that it's 8 times pi. Using our calculator, we're going to get 25.1. And then remember, it's in inches. This last one, we have just a radius. We'll do 2 pi r. 2 times 36 is 72 pi. And then if we multiply pi out, we get 226.2, and we'll label it in feet. Now we're going to combine these results. We only want the arc length for AB. We know that that's 1/4 of the circle's circumference. So 1/4 times 75.4 meters will give us an arc length of 18.8 meters. This one right here will be half of 25.1 inches, and that will be 12.6 inches. This arc length right here, we said that it's 7/18 of the circle times the 226.2 feet. So that gives us 88 feet on this part of the arc. Hopefully this helps you in understanding the difference between the arc measure in degrees and the arc length. So what is the length of an arc equal to? Well, what did we do? We found a fraction, and we found that fraction by measuring the central angle, or the arc measure, and we divided it by the total circle of 360, and then we multiplied by the circumference. So the arc length is the measure of the central angle divided by 360. Again, that's our fraction of the circle. And then we multiply that by the circumference. Let's look at a few more examples that might be like ones in your homework. The radius of the circle is 24 centimeters. And the measure of angle BTA is 60 degrees. That's this inscribed angle over here. What is the length of AB? So we were not given the central angle, we were given the inscribed angle. Do you remember how to find the arc length when you have the inscribed angle? It's twice, so this is 120 degrees. So the fraction of our circle would be 120 degrees over 360 degrees. We can reduce that fraction by a factor of 10 and put it as 12 over 36. We can then reduce again by a factor of 12 and have 1/3. So right now we have 1/3 of this circle. If the radius is 24, what is the length? We're going to have to do the circumference times 1/3. So I'm going to take my 1/3 and then I'm going to put in the circumference, which would be 2 times 24 times pi. So 48 pi times 1/3 will give me 50.3. And then I need to look at my units. What was it measured in? It was measured in centimeters. Always make sure that the arc length is given with its units. Last example. This one we're going to go a little bit backwards. So the length is given, the arc length of ROT. That's a large section, is 116 pi meters. What's the radius of the circle? So we're looking for the radius. We're going to have to work backwards. We know that the minor arc is 120, so the major arc has to be 360 minus 120, or 240 degrees. So we know that the fraction of the arc that we're working with is 240 over 360. We also know that we would multiply that by the circumference, which is 2 pi r, to get our arc length of 116 pi. I'm going to reduce this fraction to 2/3. I'm also, at this point, going to divide both sides by pi so that we don't have to work with that irrational number. So 2/3 of 2r is equal to 116. Now I'm going to divide by 2 next. I'm trying to get r by itself. So I have 2/3 r is equal to 58. Now when I have a fraction, if I multiply by the reciprocal, it would be 1. So over here, I'll get 1r. So these cancel and I'll just have r. Then I'll multiply this side by 3/2 and I will get 87. And so now I know that r is 87 and I want to give it with units. So I'm going to put 87 meters. And that's it.